So in this question, we have two trolleys, P and Q, connected by a rubber band. So here is P, and here is Q. Connected by a rubber band. Their rest, the mass of Q is twice that of P, so this is M and this is 2M. Are pulled apart so that the band is stretched and then they're released. So now we've got them stretched like so. P and Q, where this is 2M and this is M. So we know this is a conservation of momentum situation because we have explosions. We have an explosion or a collision in this case. A collision is about to happen. So we know that the momentum is the same at all times. Well, initially, before it's released, the momentum is 0. So that must be equal to the momentum afterward, which would be the momentum of P plus the momentum of Q. So that must mean that the momentum of P is equal and opposite to the momentum of Q. Well, the momentum of P is mv, call that v1, and the momentum of Q is 2m v2. And what we want to know is the ratio of P to Q. So let's get P to Q first. So P is V1. So we then have V1 is minus 2 M V2 over M. The M's cancel. And so the ratio of V1 to V2, bringing V2 over, is minus 2. But they're not asking for the ratios of the velocities, they're asking for the ratios of the accelerations. Well, acceleration is delta V over delta T. So we know the delta V is twice as much. The question is, how do the delta T's compare? Well, the particle Q is going to accelerate because it experiences a force. And particle P is going to accelerate because it experiences a force. The time of those forces are the same because it's the same force, the same rubber band force pulling them together and causing them to accelerate. So the T's are equal. So whatever the ratio of V1 to V2 is, so too is that going to be the ratio of A1 to A2. And you could see then if we divide them both by delta T's, those delta T's cross out, and so those ratios are the same. Therefore, the ratio is 2. Now, the other way we could think about this one is purely conceptually. Purely conceptually. In this case, we have the rubber band attaching these two masses, and we release them. It stands to reason that the velocity of P is going to be greater than M. So P must be greater, which is going to produce a whole number. Well, we know the velocities aren't going to be the same. That would be the 1, and the only choice that's greater is 2. A and B say that P is going to travel more slowly than Q.